Hello friends, welcome to our channel. Let's look at today's daily challenge problem. So here we want to find the final result of the given list after removing anagrams. So here the remove operation is the following. So we choose one index I. So notice that this I is strictly greater than 0. So it has a previous one from the left. So if the two words which are adjacent are anagrams, so we're going to delete the latter one, right? So we want to keep performing this operation as long as we can select an index that satisfies the conditions, right? So here, if you look at example 1, so these three are actually anagrams, so we need to remove these two. And these two are the same. Of course, they are anagrams, therefore we need to remove this one. So finally, we are going to have A, B, B, A, and C, D. So in the second example, so all of them are not anagrams, so we just return the original words. So here, actually, this problem is a small size problem because the length of this list is bounded above by 100, and each word has a length bounded above by 10. Meanwhile, so each element in the list consists of lowercase English letters. So we know that English letters, lowercase, there are 26, right? Therefore, we can actually make a list to encode the word. So each word, so we're going to map it to an array. So we are going to count how many A's, how many B's, right? So count of characters from A to Z, right? So this will be encoding. This is a 26 dimension vector, right? So two words are anagrams if and only if this encoding are the same, right? So we can use this way to do this problem. So here we can do this. So we use a list and put the words, right? Then we continue and put another one. So what we want to check is that in general, if the previous one in the list and the current one are anagrams. So if they are, so we just ignore the current one, right? Otherwise, we just add it to the list, right? So here, the algorithm is rather straightforward. Let me write the code, and in between, we're going to make the algorithm clear. So first, let me define an encode function. Encode. So given a word, so I'm going to map it to a 26-dimensional vector. So here, let's see, vector. It's going to be a list. So 0 times 26, right? And then what we are going to do, we are going to for character in word. So what we want to do is to count the frequencies. So the vector, so here the index I'm going to use is the order number of this character, so relative with respect to A, right? In other words, the character A corresponding to index 0, and the character Z corresponds to index 25, right? So this is an increment by 1, right? So we just need to return the vector. So now with this hyperfunction, so we can construct the result using the algorithm. So basically we iterate for word in words. So what we are going to do is to check if the result currently is empty, right? So if not result. So this is the one. Or the result is not empty, but the words and the current words have different encodings, so we can add the current one. So the encode of result, the top element or the tail element, does not equal to the encode of the current word. So this way we can append the current words. So otherwise, so just continue, right? So actually you don't need to write it like this. So so now you can return the result variable. Let me run it for a test. It passes two test cases. Now let's look at the generic case. It passes the generic cases. So logically, so if other case is the result is not empty, or the encoding are the same, because the encoding are the same means that there are anagrams, and the latter ones are going to be deleted. So we can keep this way, right, without just the else block. So you can run it, and then you can submit that. Yeah. So overall, so the code will be rather clean and the error short. So that will be the full code you submit, right? So here, actually, the main idea is the following. So if using this current encoding, then the two words are anagrams if and only if they correspond to the same encoding vector. So once we have this, then we can use this to filter out those to be deleted, right? Then we get the return. So with that said, I guess that's it for the current daily challenge problem. Thank you for watching.